Hello, Math 5a students. So this is a problem from section 5.4 on the log scales. And this is a problem from the textbook, problem number 36. And it says, on April 30th, 1986, an earthquake in Mexico City measured 7.0 on the Richter scale. And on September 21st, a second earthquake occurred, this one measuring 8.1, hit Mexico City. How many times stronger was the September quake than the one in April? And I'm just going to note also from the Yoshiwara textbook that they've given us this information that a method for measuring the magnitude of an earthquake compares the amplitude of the seismographic trace, so how big was the earthquake, with the amplitude A naught. So this A with a subscript 0, we read it as A naught. Change this color. We pronounce this, we call it A naught. The naught for 0, so it's an A sub 0. It's something we use all the time, usually, bright green is hard to read, often for a time equals 0, but in this case it's such a small thing that you can't even tell that it's there. And so that one is constant, it's not something that's changing, but it's that's our smallest detectable earthquake. And so we're comparing our earthquake with an amplitude of A to the A naught. And the log of the ratio is the Richter magnitude M. So M is the Richter, the scale, the number on the Richter scale. And this process is like A sub naught. It's again something we see all the time in science where we're decorating our letters with subscripts and superscripts and all that. So it's something we want to get used to because if you're going to go take any kind of science classes or something like that, you'll have to do that a lot. Okay, so what we're doing here is we're using this setup with the M equals log of A over A naught, but we have two different earthquakes that we're working with. We have an earthquake that hit in April and we have an earthquake that hit in September. So just like a good scientist, you have two magnitudes. You have an M value for the first earthquake and an M value for the September earthquake, and you have an A value for the April earthquake and an A value for the September earthquake. So it's good to decorate your letters yourself, right? So we have an M value for the April earthquake. So I'll use A for April is equal to, by this equation, log of A. So again, the A has, and for the April earthquake, divided by A naught. A naught, again, is the same no matter what. It's just the smallest detectable earthquake. And we have the exact same setup, but I'm going to use different subscripts for the September earthquake. So we have a magnitude sub S for the September earthquake is log of A sub S. Again, the September earthquake also has an amplitude divided by A naught, which again is the same no matter what. Okay, and then they told us that the April earthquake measured 7.0 on the Richter scale. So this is equal to 7.0. And the September earthquake equals 8.1 on the Richter scale. So the M value is 8.1 for September. And they want to know how many times stronger was the September quake than the one in April. And so what they're asking us to do, how many times stronger? They want us to compare this A sub S value with the A sub A value, and they want it by multiplication or division. And so logs take our multiplication or division of these two things, and they turn it into subtraction. So what we're going to do is we're going to take our two magnitude values, those are the numbers we have, and we'll subtract them, because if you want to compare things, how much bigger was something than something else? One thing you can do is just add and subtract. And another thing you can do is multiply, or say how many times bigger. They want to know how many times bigger, but we're going to subtract first to compare these two things, and then the logs will turn that into division for us, multiplication. So what we're going to do is we're going to take this M sub S value, and I'm going to subtract M sub A. I like to do the bigger one minus the smaller one, so I get a positive number. So we'll do M sub S minus M sub A. And on the one hand, we already know those numbers. It's 8.1 divided by 7.0. I mean, not divided by 8.1 minus 7.0. That's just what MS and MI are, and we get 1.1. But we also know that MS is log of A sub S over A naught, and MA is log of A sub A over A naught. So this 1.1 is also equal to, equal this way, M sub S, which is log of A sub S divided by A naught, minus log of A sub A divided by A naught. And now we have to subtract two logs. That's the same as division on the inside. So this is log of A sub S over A naught divided by A sub A over A naught. And we know when we're dividing two fractions, you flip the bottom ones and multiply. So this is log of A sub s over A naught multiplied by A naught over A sub A. These A naughts cancel, right? They shouldn't, which makes sense. They shouldn't have anything to do with this. So this is comparing these two things. Log of A sub s over A sub A. The amplitude for the September earthquake over the amplitude for the April earthquake. And this is all equal to, if you trace it all the way back, equal to 1.1. So we can, I probably shouldn't circle this. Okay. So all of this means that we have 1.1 equals log of A sub s divided by A sub A. Right, we know that for our class anyway, when you have log and there's nothing written down here, they really mean log base 10. So we can rewrite this in exponential form as 10 raised to the exponent 1.1, which is the log of A sub s over A sub A, and multiply. So this is 10 to the 1.1 multiplied by A sub A equals A sub s. And so this mathematical equation tells us right away that A sub s is 10 to the 1.1 times stronger than A sub A. So the September earthquake, always write a sentence, was 10 to the 1.1 times stronger than the April earthquake. I hope that helped clear up how to approach some of these log problems.